All right, so picking up with this last question, what should you consider to be an unusually high miles per gallon and unusually low miles per gallon? So what do we consider unusual?
An outlier. Above, like 3 standard deviations. Or is it like above or below?
Well, yeah.
Okay.
If it's not 3 or 4, it's got to either be above or below that.
Like above 3 and below 3. Oh, she's here.
So,
So like,
how about anything 2 standard deviations from the mean is unusual. So in this case, the unusually high is going to be 37.2 miles per gallon or more. Unusually low, 12.4 miles per gallon or less. All right. On the driving range, Tiger Woods practices his swing with a particular club by hitting many, many balls. When Tiger hits his driver, the distance the ball travels follows a normal distribution, 304 yards, 8 yards, so that's mean and standard deviation. What percent of Tiger's drives travel at least 290 yards? We're actually not going to draw a picture for that one. At least 290 means
Anything above 290 and including 290.
so 290 or more. So a couple ways we can look at this. We could use the table, which I keep forgetting to print for y'all, but they're in your book. We could find the z-score. So we could do 290 minus 304 divided by 8. And that would be minus 1.75. And then we could go to the table, and you could get the value from the table for the percentage that goes with that. Or we can use our best friend, the calculator, and use normal CDF. Okay, so remember that's under second VARs, and then I think it's option 2 is normal CDF. And in order, you'll type in 290, 400. So 400 is my upper just because I know that it's not going farther than that because 400 is a lot of standard deviations away. So the likelihood of that would be very slim, so I'm putting in 400, but you could use like 1E99. It'd be just fine. Mean is 304, standard deviation is 8. And that's going to give you a decimal value, which you'll turn into a percent.
where did you say that normal CDF?
Second VARs.
How do you put all those numbers into the normal CDF without it being just one number?
Yours should have brought up a chart for you to type it into.
Second VARs.
And then normal CDF.
Weird. Okay. Sounds good now. That's what I do.
So then the lower is going to be 290. And then 400.
Do I hit enter and then?
Yeah. And then 304 and
Okay,
8.
I see.
And then paste. So then I just write it as it shows up on your display screen.
I got it. Okay.
So then what percent did we get?
Like 96%.
96%. So if you did the table, you would be in the one that's the negative 1.7, and then you would be in the other one that's the 0.05, and then you would have gotten something around 96%, give or take a little bit. What percent of Tiger's drives travel between 305 and 325? Okay, so 305 to 325. So basically, the mean is 304, right? And so 305 is going to be like right there. And then it doesn't need to be exact, but 325. So I'm looking in this region here. Okay. So now I'm doing the same thing. I'm doing normal CDF. Now my lower is 305, upper is 325, mean 304, standard deviation 8. Okay, you could also find the z-scores individually and then subtract them to get the percentage from the table. If you did that, you have a z-score of 305 minus 304 over 8, just 0.125. A z of 325 minus 304 divided by 8, which is 2.625, and then you would just have to subtract them to get subtract the percentages from the table to do that. But I like using the calculator. Do we get a percent?
44.5.
45%. Okay, on those ones. All right. What distance would a ball have to travel to be at the 80th percentile of Tiger's drive lengths? Draw a picture. So with this one, okay, we got our mean is 304. We're trying to figure out what value this needs to be over here to be at the 80th percentile. Okay. So this means a drive farther than 80% of his drives. Anybody remember what our calculator function was for this when we did it the other day? If not, it's okay.
So we go second, bars, and INV norm.
Yep, INV norm. And you type in the percentile as a decimal. Remember, it'll say, I think it says area. It's actually what your calculator says. And then mean and standard deviation. And these things are going to have, hello. We're just finishing up this problem. You're going to have units on it. So don't forget that.
So Mrs. Quinn, I think Josh Krebsman's calculator has the tail where you can choose left, center, or right. What are we doing?
Left.
So the tail is where it like chops it off.
Yeah.
Okay. Like just like
My
visual.
calculator doesn't do that, so I always have to think about it. Let me put it in just to check. They have fancy calculators.
Fancy calculator. You know, I went to high school before there were calculators. We actually got some of the first ones because we were about 2 miles from Texas Instruments.
That's great. I think tell me what left gave you.
310.7.
Okay, good. So, 311 yards, okay, would be how far it has to go. All right, now the next one, Josh, you and I are going to have to do something different than they are because of the calculator being different. So 75% of Tiger's drives are above what drive length? So that means we've got, our mean here, 304. We're trying to figure out what this value over here is. Okay, so we're looking at 75% are above what drive length? So the top 75% is what I'm looking at. So, one second.
So what do you guys put in like 0.
So we're gonna put in,
0.25.
Yeah, so we're putting in 0.25, Josh, you and I, because our calculator can only calculate the left side. So we have to basically do 1 minus 0.75 to do this, okay, because ours can only do the left side. Because theirs can do the right or the middle or whatever, they are going to type in 0.75 and right for right tail, because that's where we are on that side. So on the old calculators, not even that old, but whatever, we would put in INV norm 0.25, 304, and 8. And then on the new one, you're going to put in INV norm 0.75, 304, 8, and then right. And Josh, what did you get? You, Josh.
299.
299 yards. Nathan or other Josh, what did you get?
299.
Okay, so just to show, same thing. And then the last one, between what two drive lengths is the IQR and what is the IQR? So the IQR is between what two percentages?
Q1 and Q3.
25 and 75.
25 and 75%.
Yeah.
So I'm looking at, okay, obviously my mean is here. Okay, my lower, so at 25% and at 75%, my IQR is going to be in this range here.
Well, so we know that, don't we know that the 25% is 299?
Yep. So we already know 25% because of this question was 299. And then the other one,
309.
yeah, 309.
Get that.
309.
Because you add 5 to it. Okay, so 299 is 5 below.
So IQR is 10.
Yep. So 25% is 299, 75% was 309. So then the IQR is 75% minus 25%, or 309 minus $2.99. And I know y'all already know this, but 10 yards. Now, because we were doing the 75, what you could have done was typed in 75 and left, and that would have also given you this number to have gotten that. So that would have done it for you as well. Any questions about that? All right. Do y'all want problems now? They're not typed up. Your quiz is on Friday. So we still have a couple more to go over tomorrow. What do we have? One really long problem that's like 2 pages, and then we probably won't do the wildlife example because it's not a good example. So we basically have 2 examples left to go over. And then the quiz is Friday.
Maybe not now.
So you don't. Does anybody want the problems now? No? Okay. Okay.